Swayam Prabha. Digital India. Educated India.
So, let us resume our 8th lecture. So, today we will be starting our lecture 8, and we will continue with our standard potential story, which is lecture 8, which is week 2, essentially W2 week 2 and lecture 3 of the week 2. And our topic will be continuation of standard potential. Standard potentials. Okay. Now, talking about standard potentials, let us jot down the objective of what we are trying to understand. Okay. The objective what we are trying to understand is to predict the voltage, that will be observed when different half cells. So, I have already introduced the concept of half cells. Okay. Different half cells are connected to each other, Okay. The standard reduction potential, now I will come to this concept, standard. So, when we talk about standard potential, it could be standard reduction potential or standard, I told you that you have to go by one, either you talk about standard oxidation potential or reduction potential. Based on that, you develop the chart. The standard reduction potential, which is denoted by E naught for each half cell, is measured by an experiment. Okay. We will come to the experiment, how you measure it. Okay. Now, let us go back for a second to this reaction, what we exactly did. So, you have this cadmium, which is getting oxidized, you have silver, which is getting reduced. So, in other words, if I have to give a philosophical analogy to this, that means power of silver to accept electron is higher as compared to cadmium. And if I had to put a reverse statement, power of donating electron of cadmium is higher than silver. Now, it is a relative parameter. I can introduce another thing, cadmium, silver, I can introduce zinc, whatever. So, now I have to give a value to that potential of cadmium and potential of silver. Now, in order to do that, what I probably have to do is I have to develop a way, I have to develop a common reference electrode, common reference electrode, and that common reference electrode with respect to this and with respect to this will give me that value by virtue of which I can say that cadmium can lose electron with much higher ability as compared to silver, or reverse statement, silver can accept electron at a much more higher ability, it has much more power to grab the electron as compared to cadmium. Fine. So, in order to develop, whether I say of oxidation potential or reduction potential, I needed that common reference electrode. With respect to the common, everything will be calculated. And if I could have a chart something like this. So, now with this background, now read the lines. To predict the voltage that will be observed when different half cells. So, your half cells are these are your half cells, right. This is silver half cell, this is cadmium half cell, fine. Different half cells are connected to each other. The standard reduction potential E0 or E0, standard reduction potential E0 for each of the half cell is measured by an experiment, and we will talk about what is that experiment which helps us to measure that individual E0 of silver and cadmium. And if I know these two values, so what we want is something like this. Say for example, this is hypothetical, what I am going to drop before I go to the experiment. Say for example, I have these elements A, B, C, D, E, F, G, and all of them have different power. Say for example, they all have different power to accept electron or different power to get reduced. Different power to accept electron and get reduced. Now, in order to do that, I needed a common reference with respect to what? Common ref. With respect to common reference, so if this is the common reference, with respect to it, I measured it. So, I see this one as a value, this one has a value, this one has a value. These are the kind of, you can give a number to them with respect to it. So, that may lie somewhere, the common reference may be something. So, maybe something is just like the pH. So, whenever we talk about the pH, so we say 7, above 7 and below 7. So, this is what we call as alkaline and this is what we call as acid. Okay. Now, exactly like 7, I needed a common reference electrode which I have to set something like say 0. I set it at 0. Now, with respect to 0, I could have positive, I could have negative. Which side of the number line you are going? Okay. Positive, I could have negative. Based on that, I will be able to give different number to the power of accepting electron or donating electron, whichever. So, at this point we will only talk about the accepting electron because we are talking about the reduction potential. So, now the critical question is what is that standard electrode? Now, we are going to talk about that standard electrode. So, what is that experiment? Now, let me draw the standard experimental situation and then I will explain it. Okay. So, the standard experimental situation is slightly more complicated than what you saw previously. So, okay, by the way, we are first dealing with the silver half cell. So, that is what we are going to deal with. So, the half reaction of interest at this point is silver plus electron is solid. So, essentially we are talking about this side. We are dealing with this half reaction at this point first. So, this is what we will be. So, the half reaction of interest is in which occurs in the half cell at the right. So, let us define which is where it is happening, which occurs in the half cell at the right, and remember it, connected to the positive terminal of potentiometer, positive terminal of potentiometer. Okay. So, here one more thing what I wish to highlight. So, with respect to this reaction, so standard means, when we talk about standard potential, so we have to say what the standard means. Potential we have already defined. Standard means that activities of all species are unity, that activities of all species are unity or 1. So, for the reaction what has been mentioned above, what will happen under standard condition, under standard conditions, the activity as denoted plus is equal to 1, and by definition the activity of Ag solid is also unity. We will come later into that. What does that mean? Solid is also considered as unity. Okay. Now, let us draw the half cell and its reference cell. So, here you have the Ag electrode, okay, silver electrode sitting. Okay, and so you have the salt bridge connected out here. I am not getting into in depth of the salt bridge anymore because we have already dealt with it in the previous class. So, previous 2 classes we have dealt with it rather, salt bridge, and so here your activity of Ag is essentially Ag plus is Ag plus is equal to 1, and on the other side what we have is the voltmeter sitting here, which is the positive terminal of the voltmeter, And on this side what you have is, now this is the part, the first electrode in this course what we are going to deal with is, now we are introducing that. Okay, and it's coming down, and there you have a platinum sitting here. This is a pure, and I'll give you the details of what it is in a second. Let me draw it out, and here we are bubbling hydrogen gas, H2 gas. Of course, that also has an activity of H2 is equal to 1, which is the activity is unity. Okay, so there you have a glass tube. Essentially, you have a glass tube. You have platinum. You have bubbling of hydrogen happening out here. So, I am just showing the hydrogen with the green bubbles out here, and the solution on this side is essentially HCl with an activity of again unity. This is your HCl, okay, and where activity of H plus is equal to 1. Okay. Now, the left half cell is connected to the negative terminal of the potentiometer. What we have done here is, so this is your left half cell, okay. The left half cell is connected to the negative terminal of the potentiometer, and this is called standard hydrogen electrode. Standard electrode, or SHE. Now, let us talk a little bit about SHE first. What is this whole platinum thing? So, what you see out here, so there are 3 points what I wanted you people to remember. Point 1, finely divided surface of platinum electrode. Okay. Then the next important point here is HCl solution with an activity of H plus ions as 1. So, that gives you a catch. In case HCl solution H plus activity is not 1, then we will see a different kind of drift into this electrode. Okay. So, keep that in mind. This is very important. So, these points what I am mentioning is exceptionally important. Okay. The third point is, after this, what is important is that hydrogen at pressure of 1 atmospheric pressure is bubbling over the electrode. Okay. And the next important point is hydrogen absorbs on the platinum forming the equivalent of solid hydrogen electrode, and this next point is very important, solid hydrogen electrode in equilibrium with H plus. So, in other words, the at platinum gas electrode, which is the hydrogen electrode. So, essentially the reaction, what is happening is something like this, 2H plus 2 electron, and this is given a E naught value of 0.00 volt. Now, what is exactly happening on the surface of the electrode? So, this is where hydrogen is getting bubbled, and here the solution has a lot of H plus ions, and this hydrogen gas is in equilibrium with the H plus ions present there. And for this, the axiom, this is an assumption, purely arbitrarily assumption, that this has a potential of 0. This is your standard. Now, if I go back, what I was trying to tell you, so this common one is sitting at 0, which is standard hydrogen electrode SHE. With respect to it, we have different values. So, if something standing at 0, say for example, this is you have 0, so something will be above it, lower it, and we will come to that real practical values for that. What does that mean and how does that fit into our whole equation of stuff? Okay. So, now coming back where I was, so you're realizing that this is how that first electrode, when we'll be talking about electrode and potentiometry, you'll realize how this will come so handy. So, this is the first electrode we studied, a standard electrode. If you understand this electrode, and this electrode is all about an arbitrary value being set. So, what is happening on the surface? So, the important question is what is really happening here. Now, what we have understood is what I am going to draw now, what is happening on the platinum surface. So, it is something like this. So, I am using the green color to show the atoms of the platinum on the platinum electrode. Okay. So, this is the platinum surface, all in the green. Okay. 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 So, this is your atoms on platinum surface. Now, on this surface what is happening is, so there are, and it is surrounded by a milieu of lot of H plus ions, and on the other hand platinum itself is getting a lot of, let me pick up another color, H2 gas which is coming. Now, there are a very peculiar equilibration which is happening. It is happening essentially is these H plus ions are coming onto this surface, attracting with the electrons and becoming H and eventually become H2. Okay. Now, this H2 is now traveling back into this solution in the aqueous phase. So, this is the solid and this is aqueous or the liquid phase. Okay. Similarly, some of these H plus ions are coming here, giving away the electron, and vice versa, the electrons are going there, and hydrogen from here, which is getting evolved, is coming back onto the surface of platinum. Similarly, there is an electrons which are going and kind of making it hydrogen. So, the platinum surface is a very dynamic surface, and there are a lot of such possible reactions which are happening on this surface. And what is being assumed, as I told you that this is surface phenomena, what is being assumed is this. What is happening on the platinum surface is something like this. So, in a normal condition, this electrode by itself standalone will have a E naught is equal to 0 volt. And you please understand this electrode concept, because I will close in here today, and in the next class I will tell you what will happen when there will be a deviation from the 0 and what does that mean, and that will kind of give you an idea. So, this is our first electrode what we studied. Okay. So, I will close in here. In the next class we will talk about how the value will change out here on the voltmeter once we connect it to another metal of a different reduction potential. Thank you.